All right, in this video, we're going to go ahead and talk about constructing confidence intervals for a mean when the population standard deviation is not known. So in this case, the parameter of interest is still mu. I'm still looking for a population mean, which means my sample statistic, my point estimator, is still x bar. My critical value is now a t value because I am using the student t, and my standard error, sigma x bar, I am estimating with Sx over the square root of n because I don't have sigma. So these things are the big change from CIs where we do know sigma. I'm having to use the sample standard deviation as a replacement, as an estimator, and so I am using a more cautious, wider distribution for my critical value. So that changes our formula, still x bar plus or minus, but now we have a t critical value, and I should be putting a star on these and I haven't been, times, and then our standard error is Sx over square root of n. Our sentence frame for our conclusion looks identical. So we are blank percent confident that the interval from blank to blank captures, and then context from the problem. Same sentence frame. Let's go ahead and do two examples so we can see what this looks like in practice. So it says, you do a study of hypnotherapy to determine how effective it is in increasing the number of hours of sleep subjects get each night. You measure hours of sleep for 12 subjects with the following results. Construct a 95% confidence interval for the mean number of hours slept for the population, assumed normal, from which you took the data. So, we know we start with the state step, and it says I am building a confidence interval for a mean, so I know the first thing I need to do is define mean. It's the mean number of hours slept. So population mean number of hours slept. I was actually only given two more values. I know I had a sample size of 12 subjects, and my confidence level is 95%. At this stage, I have two choices. I'm going to show you them both. I know to run the formula, I need two sample values, a sample mean, a sample standard deviation. I get those by running one var stats on this. Or I use the appropriate command on my calculator. I'm going to do both on this first example so you can see what that looks like. So I know I'm going to need a sample mean and a sample standard deviation at some point. I'm going to write a blank. I'm also going to come over here. Whoops, I meant to do that in a different color. And do my critical value. So I'm going to draw a student t curve, which looks kind of like a normal curve. I'm marking it as t this time. 0, 1, 2, 3, 1, 2, 3. And 95%, I know that 95% of a normal distribution should sit within 2 standard deviations. I know that a student distribution is wider, so I expect I'm probably a little bit outside of 2 standard deviations for my critical values. Doesn't have to be perfect. We are kind of guesstimating here. I know that 95% sits in the middle, but inverse t doesn't care about the middle. Inverse t cares about area to the left. It's only going to ask us for two things, area and degrees of freedom. So what I need is I need to figure out the area down here. And I know this curve is symmetric. So if I've got 95 in the middle, that leaves me with 5% for the tails. Half of that 5 goes here, half of that 5 goes here, and half of 5 is 2.5. So that's 2.5% in my left tail, my lower tail. And I need to enter that as a decimal in the calculator. So I'm going to move the decimal place 2 to the left. 1, 2. So 0.25. 0.025. And then degrees of freedom is sample size minus 1. So my DF is 11. And that's going to give us our T stars. So let's go ahead and run that really quick. Second bars, option 4, an area of 0.025, and a degrees of freedom of 11. And we get 2.201. You'll notice I dropped the negative. We don't care about the negative because we know we pick up a plus or minus in the formula. And t-scores are typically rounded to 3 decimal places instead of 2. So I would record that as 2.201. For the plan stage, I am building a t-interval for a mean instead of a z-interval for a mean. For my do, I know that changes my formula. That's x bar plus or minus t star times sx over n. And now I need that sx and that x bar. So I'm going to, on the calculator, go stat, enter, and I'm going to put that data in that list 1. I'm going to go ahead and pause here so you don't have to watch me do that. Now that our data is in the calculator, we can go ahead and run 1var stats. And I can see I have a sample mean x bar of 8.983 and a sample standard deviation SX of 1.290. So down here in my formula, I'm going to have 8.983 plus or minus, and then my critical value t star is 2.201 times, and then my standard error is 1.290 divided by square root of my sample size, which is 12. And that's going to give us our interval. So back on our home screen, we're going to have 8.983 minus 2.201 times 29 divided by square root of 12. And then to get the upper bound, I copy that and change it to an addition problem. So we have from 8.163 to 9.803. And that makes sense because that 8.98 is sitting right in between there. That's good news. We know our last step is our conclude. We are 95% confident that the interval from .163, and this was hours, to 9.803 hours captures the true, and then I'm going to copy that population parameter I defined at the beginning, which is the population mean number of hours slept. So true mean number of hours slept. If I wanted to do that on my calculator, notice we're doing a t interval. So I'm going to go stat test and see, and notice option 8, t interval. And it gives us options, stats or data, and we have our data in list 1. I just need to tell it my data is in list 1. It wasn't grouped data, it was raw data, so frequency is 1, and our confidence level is 0.95. And then calculate, and you'll notice that it gives us what we got just out to one more decimal place. So we still get 8.163 to 9.803. All right, we're going to do one more example. This next one says a random sample of 15 registered nurses in a large hospital showed that they worked an average of 44.2 hours per week. The standard deviation of the sample was 2.6 hours per week. Estimate the mean of the population with 95% confidence. So last sentence tells me I am doing an estimate with 95% confidence. So this is a confidence interval for a mean. So I'm going to start with the state. Mu equals the population mean. And what am I estimating? Registered nurses showed they worked an average of 44. So this is the population mean number of hours per week that nurses work. Specifically registered nurses, so RNs. They give us some data. It says random sample of 15, so N is 15. Average of 44.2 hours per week, so X bar is 44.2. And then we're told the standard deviation of the sample, so SX is 2.6 hours per week. I'm also given a confidence level, 95%. And it would be tempting to go back up here and say 95%. Can I just use that same critical value? And the answer is no. This T star is going to be different than this guy's T star because we have different degrees of freedom. This guy had a degrees of freedom of 11. This guy's going to have a degrees of freedom of 14. I expect his critical values are going to be closer to 0. Because as my sample size goes up, those long tails squish in towards the middle. We're going to go ahead and do that. I'm going to do it quickly off to the side because I know that this is still true. It's still 95% in the middle, 2.5% in each tail. So that inverse T command is going to look the same except for the degrees of freedom. Second bars, inverse T, same area, but now degrees of freedom is 14. So we get critical value of 2.145, which you'll notice is smaller than 2.201. Not a whole lot, but it is smaller, and that's what we expect to see. We are doing another T interval for a mean. I know it's a T interval because I have SX, not sigma. So I'm going to do X bar plus or minus T star SX over square root of N. And I'm just going to plug in what they gave me. So I know my mean is 44.2. My critical value is 2.145. Sample standard deviation is 2.6. Sample size is 15. Whoops. So we get 42.760 to 45.6399 is going to be 640. and 44.2 sits right in between that. So that is perfect. I'm going to skip the conclusion here. We know what it should sound like. We are 95% confident that the interval from 42.67 hours to 45.64 hours captures the true mean number of hours per week that registered nurses work. But I'm going to spare you watching me write that. I am going to show you on the calculator what this looks like. So if I want to do this calculation on the calculator, stat tests t-interval, and this time we had summary statistics. They didn't give a list of data. So I would enter those summary statistics: 44.2, 2.6, sample size of 15, confidence level of 95. And you'll notice it gives us the exact same numbers that we calculated by hand. All right, if you have any questions on performing confidence intervals for means when we don't know the population standard deviation, feel free to send me an email or drop by office hours. Otherwise, I'll see you in our next video.